Welcome back to Math 104. What is the probability that someone who tests positive for the Zika virus actually has the disease? The probability we have to compute is a conditional probability. It focuses just on those who are already known to have tested positive. We are asking, for those who test positive, what is the probability of actually having the disease? In our ideal dataset, out of 100,850 people who have the disease, that's our denominator, that's the size of our new sample space, we draw from them, and there are only 950 who actually have the disease. This is approximately 0.00942, a very small probability. Your friend who tests positive still has only a small chance of actually having the disease. Now, how could that possibly be? Here's the key point. A huge number of people in the overall population do not have the disease. Even if it's only a small fraction of them who test positive, who receive false positives, that number who receive false positives is much greater than even the total number who actually have the disease. As a result, there are very few true positives among all the people who test positive. This problem is not just an exercise in a math course. This has everything to do with real life, and it is something that everyone should understand. You will need to make medical decisions in your life. You will be tested for diseases. You need to understand what these test results mean. We said at the beginning that the test has a 0.95 probability of detecting the disease in someone who really does have it. This is the conditional probability that if someone has the disease, it will register as a positive test result. This is called the sensitivity of the test. Suppose we increased this to 0.99. That actually has a very small effect on the probability that a positive result really is a true positive. We still have this phenomenon that your friend who tests positive probably does not actually have the disease. Well, does that phenomenon go away if we raise the other probability, the probability of correctly finding that someone who doesn't actually have the disease doesn't have it? In other words, returning a true negative to those who don't have the disease. That's called the specificity. After we raise this to 0.99 as well, so we can say in both respects the test is 99% accurate, there's still only a 9% chance that your friend who tests positive actually has the disease. It's still the case that the number of people who don't have the virus is so vast compared to the number who do, even this tiny fraction of that large number still overwhelms, still far outweighs those who have the virus and test positive. What's the practical conclusion? When your friend comes to you frantically saying, "I just tested positive for this disease, what should I do?" your answer should be, get tested again.